So on this one we have excuse me, sneeze again. Alright, problem 6, 7. So for this, we've got a power supply here. We've got a switch. Single pole, double throw. I'm just going to go down here. Now the fun starts. 8. This one is this. Okay, this is 6, this is 3 L1, L2, and this is 30 volts. Alright, so what is this saying? For the circuit, determine I0 of 1, I1, and this is I2. So the current's going through these, and this is going to flip at t equals 0. So, alright, let's just examine what's happening here. For the negative infinity to 0, we have our voltage source. Our current's going to go through here. It's going to split between these two. More of it's going to go to this one because this resistor is less than this one. So we have a voltage divider. Actually, we have a current divider right there. Excuse me. Current divider. And we have a voltage divider between these two. But anyway, this is a current divider coming down. More of the current's going to go here, and that is going to saturate both of these up long term. So these are going to be filled with magnetic field and just going to be shorts. And then it's going to switch over here, so we're going to cut this piece out. So there's going to be no voltage source for the second part. And then these already have a ton of current stored up in both of them, so they're going to dump current out into the circuit to flow back to ground. And then at infinity, everything's just going to be blank. Not going to be anything happening here because these are going to be drained and there's no way to recharge them. So let's look at this. Let us draw this. What's it asking for? Determine I1 of 0 and I2 of 0. That's it? This one's even easier than I thought. Cool. So what we're going to do here is, first bit, we're going to solve these suckers. So let's just draw this as it is. So this gets drawn out, and this is our drawing positive, negative 30. It's going to go through here. Going to go through here into our inductor. This is go through here into our inductor and back around. And again, at this is t equals 0 from the negative infinity to this. This is just going to become equal to a line, because again, these are going to fully saturate. If they're fully saturated, then this is just a line. So now we've got an 8 ohm, a 6 ohm, and a 3 ohm. These two are in parallel, this plus is in series, so that's really easy. So we get 3 times 6 over 3 plus 6, and then this is going to be plus, what is this, 8. And so 3 times 6, 18, divided by 9 equals 2, plus 8 equals 10 ohms equals R equivalent. So that's the total resistance for this bit. So the next bit that we have equals V equals IR. And we're going to get our I is what we're looking at from the negative infinity to 0 side. So this is going to be our V equals 30 divided by our total, which is 10, equals I of 0 from the left side. All right. And so that means our I is going to equal to 3 amps. Let's just write that sucker down. So that's our I total coming out of this supply here. And it's asking us to find the portion that's going into both of these. So this is pretty easy. Look, we have 100%. So 3 is coming in. This one is a third of this. So we know that 1 amp is going through 6 ohm, and 2 amp through 3 ohm. And that's because, again, you have 3 coming in, and this is 1, 2, 3. So if you break this into thirds, 2 thirds and 1 third. So 1 amp through this, 2 through this, 2 plus 1 equals the 3 amps total. And so that's our I1 and I2. Do we need anything else for that? No. I1 of 0 equals our I1 we said through the 6, that's going to be 1 amp. And our I2 through the 3 is going to be 2 amp. If you don't follow what I just did here for this, what is this? This is a current divider going through there. So current divider equation. And that is it for that one. Well, that's nice and easy. Cool.